My name is Henrietta Budai, Secretary General of Hungary Green Building Council, the host of this event. Thank you very much for attending this online Green Talk, being part of the World Green Building Week programs. Our speakers today are Rudolf Nanne, green developer and founder of Footprint, and Johannes de Blok, senior developer, director of the Dutch company, the Footprint, of course. And we are honored to welcome the ambassadors of the Kingdom of the Netherlands, Mr. René van Hal from Hungary, and Mr. Henk van der Kwaas, it's quite difficult, from Slovakia. This event is patronized by the two embassies and organized together with the Green Building Council of Slovakia. And we thank the financial support of our sponsor, Saint-Gobain Hungary, too. So I kindly ask Mr. Ambassadors to give some welcome words. Thank you.
Yes, thank you so much. Am I audible and visible for everyone?
Yes,
thank you. My name is René van Hal. I am not only ambassador of the Netherlands in Hungary, but this week I also have the pleasure and the honor to be the patron of this week that has been organized by this beautiful initiative. And of course, a warm welcome to the Green Talk that we will have today. If I look back on what we have been doing, I can truly say that the Hungarian Green Business Council has really developed into becoming a strategic partner to our embassy. And why is that? First, what I see is, and of course, as a Dutch ambassador, I'm happy about that, is that I can see that there's really a lot of cooperation and also a lot of interest from the Hungarian architects community in Dutch practices. But of course, we organize these weeks not only to learn from the Netherlands, but also vice versa, for the Netherlands to learn from Slovakia and Hungary.
Természetesen mi is nyitottak vagyunk, érdeklődésre hallgatjuk a magyar és a
Magyarska podučili.
Economy and climate change. Super important topics that made this council a truly strategic stakeholder for the Netherlands. I'm now going to use a difficult word, biophilic design, or at least it was for me a difficult word. But I think it is an interesting development in architecture and in interior design, an approach that incorporates natural features into buildings to create a more productive, healthy built environment, or to say it more colloquial, basically, how do you bring nature into the buildings and how do you design with nature in the buildings? And in a sort of in a nice way, I think it brings buildings, circular economy, and our climate challenges together. So that perhaps could be an interesting subject for a future event that we will have. Another thing, of course, that I would like to highlight now, and our chairman already did that, is that we have two speakers from the Netherlands who are doing business in Hungary and whose mission it is to make buildings greener and more sustainable. Saying a few words about buildings. This week, in a weekly publication in Hungary, HuGBC, there was an interesting article, and it said that if you think about the environmental implications of concrete, they are in many ways more pressing than those of plastic or transport and distribution. It's definitely been recognized, of course, that our buildings currently are responsible for 40% of final energy and 36% of greenhouse gas emissions in the EU. And as we have all listened last week to the State of the Union of European Commission President von der Leyen, that the EU also recognizes that built environment's significant role is there in achieving the enhanced emission reduction targets. So we have some work to do. And of course, the challenge is that we have, on the one hand, the demands of society. On the other hand, we have the wizards like the architects and the engineers, and on the other hand, the governments. And the challenge for us is to work properly together. Of course, it goes without saying that built environment is an important sector also for my embassy to match Netherlands and Hungarian business expertise. And of course, the building sector is one of them. I'm really glad also to welcome my colleague in Slovakia, because I think that we as the Netherlands can step up and further improve the cooperation within Central and Eastern Europe, just as much as the countries themselves do it. So, Henk van der Kwast, you're the second one who takes the floor, and I will wish you, dear participants, ladies and gentlemen, a very fruitful and interesting workshop. Thank you very much for your attention.
Thank you very much, Mr. Ambassador, and I give the word to the Mr. Ambassador from Slovakia.
Thank you very much indeed, and let me send you sincere greetings from Slovakia. As you can see, I'm sitting amongst the trees, so it's really a green environment. It's for me a great pleasure to welcome you all here. Despite circumstance, we are able to continue on this unique cooperation between Hungary, Slovakia, and the Netherlands that started already 4 years ago. Through our specifics and experience, we can change experiences and see how we all can do better, particularly on those issues. Slovakia is taking a very active approach to environmental topics. The government has a clear policy on those issues and is working to further promote a green approach to the future. Slovakia is also an active and constructive partner in the EU dialogue. The Slovak president, Mrs. Čaputová, presented recently her goal to make the potential presidential office carbon neutral up till 2030. It will include green roofs, green walls, and energy efficiency. So this is really a clear example, I think, to move forward. Also on construction, which is close to my heart because I am the son of an architect, but since I was not good in drawing and not good in mathematics, I became a diplomat. But it's still close and it's important. In construction, green is the way forward. 80% of newly built office buildings in Slovakia has an internationally recognized certifications for green buildings. So this is really an issue and we are moving forward on that. For instance, recently 3 new office buildings were completed with above standard certifications, so-called WELL certificates, which are recognized globally. Such buildings secure not only benefits for environment, but also for well-being of people, which is of course essential. Slovak citizens are curious about green innovations and the demand for high-quality buildings is rising here. This became even more visible during COVID times when stricter health requirements on buildings were demanded. Studies and practical examples from the last 20 years showed that design and construction of green buildings is possible to reach within a minimum increase of costs. So there is a large potential. The Slovak Green Building Council are striving for raised awareness on the importance of healthy living and healthy working. Houses greatly contribute to this. Thank you, finally, the organizers for preparing Green Building Week and giving an opportunity to share good practices from the Netherlands. And I hope we can learn from each other and help each other to do better and better for a greener future. Thank you so much.
Yes, thank you, Mr. Ambassadors, and we are really happy and proud to welcome the Netherlands and the speakers from Netherlands on the World Green Building Week programs in Hungary and with this event in Slovakia as well. So we had some cooperation in the past, and we are preparing other events together. And I think that you can give us really very good practices, the Hungarian people, and here at the Hungary Green Building Council as well. So thank you very much again for the patronage of the Green Building Week in Hungary for Mr. Ambassador from Hungary, and you, Mr. Ambassador from Slovakia, also to be here with us and saying these thoughts. Thank you very much. And then we can start the presentation, but before I have some introductory words for you. The main topic of this year's World Green Building Week is a net zero buildings for communities, for the planet, and for the economy. When we say net zero buildings are important, which are these ones? We mean net zero embodied carbon buildings. Embodied carbon emissions are associated with materials and construction processes throughout the whole life cycle of a building. So a net zero embodied carbon building is a highly resource efficient with upfront carbon minimized and all remaining embodied carbon are reduced. Now let's cover the cross-laminated timber, a groundbreaking building solution that can take place of concrete in buildings inside and out. So Johannes, the stage and the screen is yours. So please start your presentation.
Okay.
We can hear you and you can share your screen.
Okay. Jó napot kívánok, goedemiddag, good afternoon. I want to introduce myself. My name is Hans de Blok, officially Johannes de Blok. I spent my whole life in the building engineering. I studied what we called in Holland HTS and later a university in Delft. I worked several years as an architect, but later I became more and more a specialist on building physics, behavior, and project management and project development. So that is my background, and I want to speak to you afternoon about the use of wood instead of concrete and the accent on CLT, cross-laminated timber. I hope you can understand me well and you can see the whole presentation. The content of the presentation is first I start with what is concrete exactly and what is the advantages and disadvantages. Building in wood.
We cannot see your presentation, Johannes.
What?
We cannot see your presentation. It is
you
not.
You cannot
showing.
see. We'll come down.
So please click on share.
Hungarian
screen.
interpreter could see the presentation insofar.
Je moet eerst even dit uitzetten. That's very strange. You can see me, but not the presentation.
Okay, I can share it for you. So I share it.
Oh, here it comes.
So now, now we see.
Ik heb de muis nodig.
Okay.
Let's start over again.
Okay, it's fine. Thank you.
You can see this?
Yes.
Okay, thank you. The accent will be cross-laminated timber, but I speak also about other possibilities in wood. The content is, at first, I say something about concrete and what is the good and the bad things of it. From wood, building in wood, what is a zero energy house? And I want to say some words about heat accumulation and why it is that important. Concrete. Concrete is made from actually three basic materials, that is cement, sand, and gravel. We need water, about 600 liters per cubic meter to make a cubic meter beton. And then we have, in this amount, 167 liters of cement, 33 liters of sand, and 500 liters gravel. That makes 1 cubic meter of concrete. The water, drinking water, is necessary for the chemical hardening of the mixture. And then we have still not reinforced, normal, non-reinforced concrete. Reinforced concrete has also a lot of steel in it, about 500 kilos in a cubic meter. And when I show you the next one, then you see how only the cement is producing.
Is szerepel. A cement hogyan is készül? Agyagos mészkő kell hozzá, és ezt pusztán csak a természeti erőforrások között tudjuk megtalálni. és ehhez sajnos pusztítani kell a természetet, itt látható ezen a képen.
Dole tam vidíte, ako vlastne si ničíme prostredie a krajinu, keď vlastne
You see in the scheme a very complex scheme of making cement, and well, I don't want to tell all the steps of it, it takes too much time, but you can see that there is a lot of transport, a lot of storage, there is a lot of energy necessary before it is cement, and then we have only cement, and it is only a small part of the total. Concrete is a beautiful, absolutely good product for all kinds of tasks. It is waterproof, it is very, very strong. You can make big bridges and constructions of it. It is a rather long life, about 100 years when you protect it well. The beton rods you have to protect, otherwise the steel is, becomes a problem in the construction. And it has a high heat accumulation, and that is very fine because that makes buildings very stable in difference of temperature in the environment. But there are also negative points. That is, the cement is made from the marl, and that provides 9% of the global CO2 production. Compare that aviation in the whole world is only 3%. So concrete is absolutely not environmental friendly. The other stuff about the concrete, that is the sand and the gravel, is hardly to find. It is more and more difficult to find enough quality of that, and also that makes it difficult to continue building in concrete for a long time. And then, last but not least, a lot of steel we need in the concrete, and the steel comes from the ore, also from the earth, and it needs a lot of energy to make steel in the quality what we need. A lot of transport, a lot of melting, and recycled steel is also use a lot of energy in transport and melting. So altogether, we have disadvantages of using of concrete. But it didn't mean that, as you see in the picture here upside, you need formwork from wood, and mostly it is a lot of waste. And but it's also a disadvantage is that it is very expensive to demolish because of the steel in it. And so the recycling of concrete is actually very difficult and not very environmental friendly, especially the reinforced concrete. Oh, think too fast. Then wood. I think these two pictures is common for a lot of people, and that is the image what they have in mind when we're thinking about building in wood. And of course, the church on the left side is from the 13th century in Norway, and so it is proven that wooden buildings, when you treat it well, it is good for hundreds and hundreds of years. It needs some protection, but that's it. Why wood? Well, wood has one very positive point, in my point of view, that if trees are growing, it absorbs the CO2, and the CO2 actually in chemical way is broken down in two components, the C atoms and the O atoms. The oxygen goes back to the air when growing the tree, and the C atoms are stored in the wood. And if we burn wood after the lifetime of the tree, let me say 50 years, when burning wood, the CO2 comes back into the atmosphere. So exactly what we absorbed in the 50 years is coming back in maybe a few hours back to the atmosphere, and that is not what we need. So the same process is happening when you have big wooden areas, what is not production wood, and you let it rotten automatically, then also in the rotten situation, the C atoms come back in the atmosphere and the CO2 circle is closed. When we have leaves on the ground, the C atoms go into the soil, and after felling the wood, after lifetime, the C atoms stay in the wood, and that is a very big plus for wood. So the wood is a natural product, but contain the C atoms all the time in the time that it stays as wood. And when it is rotting, I told already, in a natural situation, maybe in 5 years, it will come, all the CO2 way back in the atmosphere, and when it is burned, it come maybe in a month after felling, the C atoms come back directly in the atmosphere back. So
égítés során pedig kb. 1 hónapon belül visszakerül minden. Nagyon fontos tehát, hogy a C atomok, a szénatomok, hogyha lekötjük, mint egy felhasználjuk építkezésre, akkor nem kerülnek vissza azonnal az atmoszférába, tehát a környezetbarát megoldásnak is tekintetjük ezt, CO2 szempontjából, hogyha a fából építkezünk.
Pre vír je veľmi dôležité mať tie produkčné lesy.
Erdőterület legyen, amely felhasználható mindenfajta termékek gyártására, például építkezéshez. Bal oldalt.
Of Finland, forests in Finland, they produce the growing of the wood produce actually one house every 14 seconds. And on the right, you see an example of a country who takes that very serious. In a weekend last year, they planted 350 million trees in a weekend during the National Tree Planting Day. And that is, in my opinion, a perfect example of who you go with this aspect. When you're producing wood, I had a sawmill several years, so I know exactly what are the problems to make wooden products. For instance, when you make parquet, I think from every round wood, cubic meter round wood, only 1 cubic meter is from every 10 cubic meters. So that is 10% product and waste. But the waste, and it's the left 2 pictures, is very good for making all kinds of products. When you cut the wood, you have the sawmill, and the second is when you're planing the wood. You also have, well, shavings, leftovers, and it is very good used to make all kinds of plate materials like chipboard and OSB plates. So, and also in that product, the CO2 stays in the material. When we speak about building in wood, then we have distinguished actually 2 different techniques. On the left side, you see the timber frame construction. I show you in the next 5 minutes how that is made. And on the right side, you see the CL2, and I explained it also later. What is the timber frame construction? The timber frame construction is is a wooden frame made from all kinds of wooden elements, mostly 40 centimeters from hard till hard placed. And on both sides, they have a sheet material, plasterboard or Fermacell to complete the element. Here you see an example on the picture with an extra plate, and that is a zone for all kinds of piping material. And outside there is mostly an extra insulation layer finished with a waterproof layer, for example, facade plaster. But it can also be another product. There is a good factory in Hungary who makes these elements. This is made, I think, in 2011, if I remember me well. An automatic factory to make these elements, and on the right picture you see that the elements are filled with an insulation material. here on the left also. Then there comes some foley for the water resistance, the moisture. And then on the left side, you see that the elements are ready for transport. The windows are mounted in the factory. The plaster is already made on the outside. And on this way, it goes to the site to build houses. And you see that in these three pictures. It comes by crane, put it all together, mounted it together, and on the right side, you see the end result. Normally, for a house like this, you can do it in 1.5 to 2 weeks. To build this from left to right in 1.5 to 2 weeks. So that is pretty quick. Oh, the aspects of timber frame construction. The good points are, the advantages, it is prefabricated, it's in a factory, and that means that around the year, summer and winter, it's possible to make these elements. You have to store them, and then when the weather is suitable, you can go to the building site and place them together. There is a fast assembly time, and there is a very high heat insulation possible. In Holland, we use the air value, 8 till 10. That is a normal value for zero energy houses. In Hungary, it is the U value. It is about 0.1. The disadvantage of this system is that it is a very light construction, and you can damage the plates on the inside, well, easily, let me say. It has a light mass, and that will result in a relatively low heat accumulation. And that means that a fast heating or cooling, for instance, when it is cold in the nighttime and warm in the daytime, the house will follow automatically very fast these temperature differences. And that is a big difference with I show you later in a calculation. So you can make zero houses of it, that's zero energy houses, and I made one myself in 2013 in an island in Holland, Texel. The project is called Zouterland in Dutch, salty land, free translated. This is a project in the social housing that is very unique in Holland, that we made zero energy houses in the social sector. So the rental houses for not the richest people in the country. It's only possible to rent that for till a middle income. The houses have their own solar panels for making electricity. There is a floor heating system with geothermal heat pump. I don't explain that exactly how that works, but it's because that is a lecture itself. And well, it is 120 meters deep in the ground and use the temperature of the earth to make it warmer through a heat pump. There is a connection to the electric grid, so there's also energy in the nighttime. In nighttime you buy the energy, in daytime you produce over, and in the whole year that's left under, the total produced electricity is more than what is used in a year. So there is a plus. Important for this type of projects is that the orientation is good. That means windows, the biggest windows on the south side, you use the passive energy from the sun, but you don't have to warm yourself, the sun is doing that. There is a balanced ventilation system with heat recovery system, and the insulation is about till 9, 8 and 10 meter quadratic Kelvin per watt. So this is the project. I show you some pictures of it. This is the maquette, 3 rows of 4 houses. The PVs on the roof. Here you see one stroke of 4 houses. Here you see the 3 rows. And this is from the north side. On the north you see small windows because that's the kitchen side, and you need light in the rooms. So, but they are smaller because although the insulation is good of the windows, it is not even the same quality as the wall. So reduce the square meters in the north part. Then the cross-laminated timber. It is a little bit complex to tell you exactly how it is made, but to say it in one sentence, it is a finger-jointed and laminated wooden plates glued in a crosswise direction, alternately staggered. On the right side, you see triplex. Everybody knows what it is. That's actually like the CLT, but this is not jointed, fingerprinted. It is only layers glued on each other in an alternately staggered way. I explain you what is finger-jointed wood. You see it on the left side, two pieces of finger jointing. Finger jointing is a mostly full automatic process to cut out the nuts in the wood, because that is not the best place in the wood, and automatically they make fingers on it, and then it's glued together. It is an automatically process. Left you see when it is not glued up, and downstairs you see when it is glued together. When you have this pieces of wood and you glue it on the sides together, then we have laminated or finger jointed wood. That's on the right side. I hope you can see how it looks like. This gives an example of a CLT element that can be 15 centimeters thick or something, also 20, what's necessary. And they make it in factories in very large dimensions that can be 10 meters long or more. And this is a CLT element, crosswise glued sheets of laminated finger jointed wood. It's a big explanation. Here you see some examples. This is in on the Bureau of an Architect in London. Prefabrication is take place in the factory. That means that you make elements or even complete cells that you put together. In these cells, you can make then rooms, if you like. In a year-round production, you have a much more better quality control than on the building site, and there is a very short installation time. So only pluses, in my opinion. I show you some projects made in CLT. The first building on the left side is from Andrew Wall. It's an architect in London. It is the Murray Grove. The second from left, the first row is also Whitmore Road from the same architect. I show you HoHo in Wien, several pictures about Jakarta Hotel Amsterdam, a pavilion in Eindhoven, the Dutch Design Week pavilion. What is in progress now is Hout Amsterdam. It's now under construction. I show you a project in Rotterdam made by the architect himself, Roelof Gortelmaker, and his wife. And I show you some pictures of some other projects. Let's go to the first step. Here you see Murray Grove. It is built in 2008, and when the architect told he was the firm who gives the order don't want to express the wood so much because they were afraid that people don't like the wooden building. But that's all over now. It is environmental friendly, but it is also very safe building. And 12 years old now. Also Murray Grove. Whitmore Road, another project in London. Here you see artist impression of HuGBC in Wien. I don't have pictures of it is in realization on this moment. Jakarta in Amsterdam. It is made by Björn Mastenbroek. It is only the first layer is concrete and the fundament is concrete because the concrete was necessary for in the water. You know, you see the water level in there in the canal. It's in the harbor of Amsterdam. The water level in the ground is just as deep as what you see here, 80 centimeters deep in the ground. That is normal in Holland. So we need concrete and concrete pillars and foundation. That is not possible in wood. Or Old Amsterdam is built on wooden piles. The pylons are all the time underwater, and underwater it is not rotten. So also the houses from the 16th century are standing on wooden pillows in Amsterdam. Don't forget that. Well, this is inside the building, the big hall. This is the architect himself, he's walking there. You see some views. It's a very nice building. There's a very nice atmosphere. A lot of trees in the big green hall over the 9 layers. So, another one. Another project in Holland that was for the Dutch Design Week. It is made by Marco Vermeulen. Here you see it in the building process. I think it is ready now. Here you see a whole trap making of CLT. Actually, you can make everything what your fantasy can imagine. Then we have in Amsterdam, just under construction, but here you see the artist impressions hout. This is a joke. Hout klinkt als hout. Hout is wood in Dutch, but this is the French version. Hout betekent also high. And here you see it under construction. The kernel in the center of this building is concrete because it will be a very high building, but 90% of the building is CLT. Floors, walls, everything. Then a private project of Roelof Gortemaker and his wife Jeanette Blom, architects in Rotterdam. They designed the house themselves. It is made in CLT. It was also ready under the roof, watertight in 2 weeks. So it has also great advantages. Here you see the outside is the normal brick that we see all over in Holland, but that has nothing to do with the construction. Behind that is the CLT element. And this is only a rain coat of the building. Inside the kitchen, working room with a view on the harbor, living room. And these are pictures on all kinds of other projects in Scandinavia and in whole Europe. They are also interesting, but I didn't spit it out here. The aspects of CLT, just like the timber frame construction, it has actually the same advantages. It is prefabrication in a factory, production year-round. The quality control is perfect in a factory. It's a short installation time. It has a better heat accumulation than the timber frame construction I show you later. And you can make, and that is different from the timber frame construction, high-rise buildings, as you saw. It used, of course, more wood than in relation to timber frame construction, and it is heavier in transport than timber frame construction. That's logic because there is more wood per square meter wall than the timber frame construction. Then I make a calculation about the heat accumulation of a wooden frame wall related to the concrete. It is on the left side. I use here a 10 degree temperature difference, and you see that in the speed of the energy you need to warming up is in a wooden frame house about 10 times faster than in a concrete wall.
El lehet melegíteni egy ilyen épületet, a hagyományos fából készült épületet, mint a betonnal, tehát könnyebb felfűteni. Ezt a vasfektes mindenki ismeri. Mondjuk egy katedrálist, hogyha Notre Dame-ot összehasonlítjuk Párizsban, Notre Dame-ot versétálunk, akár dögletes hőségben nyáron, az ember azonnal hűs klímát érez, hiszen elgondolt, hogy fél évbe telik, míg felfűtjük ezt az épületet adott esetben, és sosem lesz benne, meg télen sem. És mondjuk egy kempingben a faház 1 perc alatt felfűthető, viszont este bizony rendesen kihűl. Ez tehát a hő.
Akumulácia tepla je veľmi dôležitá pre dreve. Tak, keď hovoríme o CLT a porovnáme s betónom, je to len...
Kétszer gyorsabban lehet felfűteni, 5-szer lassabban, mint a hagyományos wooden frame konstrukciót, tehát a komfortérzet egészen más. Itt is pontosan a nulla energiával működőképes ház. A normál definíció az, hogy egy évre vetítve, mondjuk egy fix időtartamra vetítve, a elemekkel több energiát termelünk, mint amennyit felhasználunk. Ebben a fix időtartamon, intervallumban. Gáz nincs, elektromos őt használok Magyarországon, és ezt használom az itteni házamban. Hollandiában is van egy házam, ott is elektromos áramot használunk. És
aspect, you cannot cook on gas because there is no gas in the house. The other important part is that if you make...
Amennyiben az energiát csak magunk termeljük meg, akkor szeretnénk limitálni, hogy mennyit használunk fel ebből. Nagyon fontos, hogy nagyon jól legyen szigetelve a ház. A tanácsom mindig az, hogy legalább 8-as szintet érjünk el, vagy 0,125 a magyar szabvány szerint. Visszanyerés a szellőztetés esetében, ha lehetséges, akkor szenzorok által kontrollált ventiláció legyen. A legjobb, hogy a geotermikus energiát használunk föl. És van egy nemzetközi szabvány, a PHPP, az alacsony energiaszinten működni képes házakra, az egy nemzetközi elfogadott kalkulációs rendszer.
Certification for a low energy house if the consumption for heating is lower than 15 kilowatt-hour per square meter per year. And the houses, what I showed you in Holland, are under this level, are 40. So I started my presentation with wood, the new concrete, as an ask, and I hope that we can say soon wood, the new concrete, and because it has a lot of positive and effects for the environment, and it's also very pleasant to live in houses made from wood. So this is my contribute this afternoon, and I thank you very much for your attention, and if there are questions, then you can ask me.
Yeah, Johannes, thank you very much for your presentation. So you can stop sharing your screen.
Yep.
And we have a question arrived. And of course, we have 40 minutes for questions because the name of the event is Green Talk. So now we let the word to the audience to ask questions from you. And
Yes.
we received one question in written, so I will read it for you. It is in English. If the demand for timber construction goes up, how will the non-production forests be protected against opportunism? Or is scarcity somehow unlikely? This is the question.
I don't understand it completely.
So, if the demand for timber construction goes up, how will the forest be protected against opportunism? It is the question. How we can protect the forests?
The forest?
Yeah, which are not planted for production.
Yes.
Natural
well,
forest.
I know, for instance, the situation in Hungary because I had a wood production plant in the last century till 1996 till 1999. On that time, there was in Hungary 320,000 acre of hectare. I have to say, I don't know it in English. Is that acre? That's not exactly the same. 100 by 100 meter. 320,000 hectares of production forest, and although there was a constantly production of wood from acads, it was acads in this case, the production woods were growing because you have to renew the trees every 30, 40, 50 years. And then you have to replant.
34-40 évvel, és aztán újra kellett ültetni Magyarország esetében.
That when you want to cut trees, you also must have a plan for making new forest. So that goes hand in hand. It will always growing and growing and growing. So like I said, but that's what they do in Finland. You see a growing of every 14 seconds a house in the forest. They don't make a house every 14 seconds, but it is the volume what is growing in 14 seconds. So plant trees, plant trees, plant trees, and make production forest. It is very good for the environment because it absorbs the CO2 and it gives us material but doesn't harm the earth.
Okay, thank you very much for the answer. And we have a question in oral. I let Lena to ask it.
Yes, good afternoon. I hope that the tractor here in the distance is not disturbing too much. Actually, thank you very much for this very interesting presentation. I have actually two questions. The first question is regarding the heat accumulation. You showed that if you use a timber frame house, the house will heat up or cool down very quickly.
Yes.
I assume that you've assumed rock wool as the insulation material. Is that correct?
Yes, but it has nothing to do with the insulation. That is a big mistake, and it is a totally other aspect. Insulation.
Sorry, if I may, I understand that. The question I want to pose, because tomorrow I will do the green walk, and we built 3 holiday homes also with timber frames, but we insulated it not with rock wool but with cellulose, which is made of recycled newspapers.
Yeah,
and
perfect.
Our experiences so far is that the houses do not heat up very quickly in summer. Can that be because of the higher heat capacity of cellulose compared to rock wool, or
no?
Could it be something else?
No, but as the speed of the heating is only the heat accumulation is the factor for that. This is maybe difficult to understand, because insulation, you have only the need for insulation is only when there is a difference of temperature. That is in the winter time, when it is -10 outside and 20 plus inside. You have a difference of 30 degrees. How better the insulation is, how slower the energy goes to the outside. But there is always a transport from warm to cold. If you don't heat your house in the winter time, it is inside just as cold and it is outside. Only the quantity of the energy what you lose, that is reduced by the insulation. But that is a totally different aspect. If you have every house, when you don't heat it, it will be cooled down eventually till the temperature, what is the temperature outside.
Yeah, no, I understand that.
It takes more time when it is massive and high heat accumulation level, and it goes fast when it don't have it, compared to the cathedral with the tent.
Yeah, no, I understand that. It's just our experience is that the houses in summer, they don't have cooling, and even during a heat wave, a prolonged heat wave of 2-3 weeks, they hardly heat up. Okay, my second question would be on the foundation, because you mentioned that so far concrete is still being used as a material for foundations. Are there any experiments or technologies under development to avoid concrete in foundations or wet environments in general?
Well, we have it, of course, in Holland, the wooden pillar, the pillars in millions of it in Amsterdam. But the problem is where the groundwater is not there anymore, it don't protect. So you cannot make foundation actually in a good way in wood, because it has a very limited lifetime. So I think that unfortunately we have to do it still in concrete.
Yeah, that's unavoidable. Okay, thank you very much.
Or another stone product. That's possible, of course.
Okay, thank you.
Okay, thank you very much for the answers. We have a lot of questions arriving in the chat box and then the question and answer box. So 2 questions are about the same. So the audience is quite curious about the toxic content of the glue in the CLT. So what about the ecological footprint of it, and how you can deal it?
Well, also there is a lot of development in in that product, in the glue, but you have to realize that the glue is so little bit in comparing the total mass that I don't know exactly how much, but in a big panel from 2 meters wide and 10 meters long, maybe there is 1% glue in it, and the glue is bounded in the material and it is not coming out, and there is a lot of tests made. I remember that 20 years ago, the spaanplaat, we call it in Dutch, the OSB plates, has the same problems, that the glue, that is much more glue in it. It is actually glue with wood and not glue between the layers of wood. So in the CLT, the percentage of the glue is very, very low, and they make them also more and more environmental friendly, in my opinion. So the tests are very positive. It's not a strange smell or something, or polluting the air in the houses. That's absolutely not the case.
Okay. And this is my own question, that what about demolishment, when you would like to recycle the CLT and the glue is in that?
You
How
can
do it.
You can, the CLT, you can make the OSB plate from that. It is very simple to demolish because you can cut it with a chainsaw or something. And so wood is easy to demolish, and you can make all kinds of products from it.
Mm-hmm.
Spaanplaat, OSB plate.
Mm-hmm. Okay, thank you. And another question is that...
Or, sorry, yes, you can burn it, then when a building was there for 100 years, then not the CO2 comes in a short time to the environment, but in 100 years. So even burning is not the most worst thing to do, but you can make other products from it.
Yeah, maybe a question that is next to this question. The question is that if I would like to keep nice wooden material look from outside, is it possible to let CLT uncovered without any protective material, for instance, lacquer, because this is the same question than the glue? So I
don't advise to do that. I advise an extra layer, because the outside must be the raincoat from the building. So I think it is not handsome to have the wood construction outside, but there are all kinds of woods specially made for cladding on the outside of the building. For instance, thermo wood is one of the products that is impregnated wood that can stand for 20 years outside, and you can then also renew it if you don't like it anymore, or paint it or whatever.
Okay, thank you. A lot of questions are arriving, so the topic is very interesting, so I try to summarize them. A question is that does Dutch standard material calculation give yet no significant, Dutch standard material calculations give yet no significant advantage for CLT buildings compared with concrete? So what is your opinion about that, or your experience?
The heat accumulation?
No.
You mean?
The standard material calculations give yet no significant advantage for CLT buildings compared with concrete. The material calculations.
Yeah, what kind of calculations? You mean the price, or you mean the environmental behavior? Or?
I asked Mr. Martin to maybe write the question other way, because I can just...
Or statistics.
What is written, yes.
Statica.
So till there is another question, that waterworks in Holland use wood using finger junction to optimize the use of tropical wood underwater and the other wood above water. Why would this technically be not possible for foundations works?
I think it is possible. It's only the time life what you have. Of course, there is all kinds of woods are very good in water construction, like azo-bay. That's really much used in the harbor in Amsterdam in the 16th, 17th, 18th century, and you still can find it. We have a special product where the ships goes to the yeah, hoe heet de kade? Wat is een kade in het Engels? I'm looking for a word. We have a word for it, remmingwerk, where the ships are landing on the side of the water. They make it always from azo-bay. That is a very good wood to keep in the water, but it has a limited time life, and not 100 years. It is maybe good for 20 years, 30 years. And for building foundation, I don't advise it myself. If you want to keep the building for a longer time than 50 years, I don't advise wood. But that's my personal meaning.
Okay, thank you. And the former question is about the ecological calculation.
Yeah.
Regarding CLT versus concrete.
Yes.
So what about the advantage for CLT compared with concrete regarding the ecological calculation?
The CLT absorb the CO2, and that is what we want in the whole world. So reduce CO2 is very important, and using cement, you have seen that it is only the concrete is 9% of the worldwide CO2 production. So to stop with concrete or limit it till 10% from what we use now, that is already a very big advantage. And to have more forest is very healthy for human being and for animals. And in the meantime, and later we can cut the trees and make CO2 from it. So it will bound the CO2 of the whole lifetime of the product. So that is an advantage. This is tremendous big, in my opinion.
Okay, thank you. And there's a financial question. In terms of costs for the material itself, as well as the whole building, meaning process, construction workers, and so on, is the CLT construction more expensive compared to concrete and steel?
Two opinions about it. The English architect told no. If you calculate everything, the speed of building and so on, it is more or less the same price as a concrete traditional building, because it is 1 year faster in production. So that is his opinion, and the architect of the pavilion in Eindhoven told that it is a slightly more expensive on this moment. So there is not a big difference. And when we produce more and more, my idea is that the price will go down.
Thank you. Another question. Could we estimate a maximum lifetime of a high-rise CLT building at this point already?
I think it is not shorter than concrete, because I show you the church in Norway. It's 700 years old, still standing there. There is, for the construction, there is no limited time, in my opinion.
There's a question about
maybe even longer than concrete. You know, concrete is not without problems. When the water is coming in the concrete, the steel will rust and by oxidation, and then you see here in Hungary a lot of examples. For instance, viaducts were not good treated in the time, and you see a lot of cement is springing out the construction, and that makes it limited. So I think even a wooden building can stand longer than a concrete building.
Mm-hmm. There is a question related to this previous one, that what about the damages or cracks which could affect any of the parameters of material during the years? For instance, you mentioned a project from the 2008. What is your experience? Any damages, cracks?
Nothing, I think, because that building is made from walls from 15 centimeter massive CLT, and that is as strong as concrete. You cannot make a hole in it.
Mm-hmm. And there is a question about the structure, that how different are the construction accuracy tolerances between CLT and concrete construction? Can it introduce certain difficulties during assembly?
Well, I don't think so. Most of the constructors can calculate in both systems, and they can make buildings in steel, wood, concrete, and everything. So there is to calculate makes it not complexer. Even I think that concrete calculation is complexer because the steel is for the trekkracht, the pulling force, and the concrete is the pressure force, and you have always to design the exactly place and quantity of the steel in the concrete. Wood is all made of wood. There is no difference between the sides. It is good for the pulling and the pressing forces.
Mm-hmm. Thank you. There is another question related to the structure or the qualities of CLT about vapor transmittance. So do you need additional vapor protective layers, or are the joints tight enough to provide enough sealing?
I calculated myself that you know, to vaporize, that can be a problem in some kind of construction. Then you can have in the construction condensation, but in CLT that is not necessary. It is only, you saw also in the house in Rotterdam that they, and in the hotel in Amsterdam, you saw the wood panels are not covered with anything on the inside. You can see you can leave the wood as you like. There is no layer necessary for the humidity to hold. And in the timber frame construction, you need it. Behind the gips carton, you need a layer of a foley to protect that there is condensation in the element. Okay, so that's the building physics part for me.
Yeah, and sorry to interrupt you, that I kindly ask you to use only English words, not placing Hungarian words in your speech. Because the Slovak translator cannot translate Hungarian to Slovak. She doesn't speak Hungarian. So thank you very much. And we can continue with the questions. Another questions, we spoke about the vapor, and now we can speak about fire. So what about the fire protection issues?
It is in Hungary. It is allowed to build in this the Hungarian rules, the Magyar Szabvány.
Please don't use Hungarian words. Please don't use Hungarian words like Magyar Szabvány. Please say it in English. Thank you very much.
That is the norm. That's the norm that is here valid. But also in Holland and in England, it is completely according all the regulations. So there is no fire problem, not at all, because it is massive. They know exactly that when a building is in fire, it burns with a speed of 0.7 millimeter in an hour or something. But I don't know the figures exactly, but they know exactly how fast it will demolish, and there is time enough to leave the building. A concrete building is not safer. And a steel building is even worse, because steel is absolutely not safe by firing. It's melting. It lost its power. Yeah.
Thank you. And after fire, there is sound. So what is your experience with the acoustic? This is a challenge by the CLT construction?
Yeah. Don't expect miracles from it, but acoustical in the sense of the echo in a room, it absorbs more than concrete. So the acoustical values are a little bit better than when you have concrete walls. But there is another aspect of acoustic, and that is the insulation quality. Then it's actually the same as in the heat accumulation. The concrete is the best. Then comes the massive wood. It is nearly the concrete. And then the lightweight timber constructions are the worst in case of that. Have the less resistance.
Thank you. So there is a question about the material of CLT. So is there always one type of wood that the CLT panels are made of, or not?
No, there was one picture when you saw in the laminated timber that there was one piece of other type of wood in it. That is the advantage of fingerprinting. You can combine that several types. They do it in the window industry. I was supplier for many years for the factory in Holland, and I delivered the Hungarian acacia, Robinia pseudo-acacia in Latin. And he makes now window frames where only the bottom of the of the verticals are made from acacia wood, and the rest is spruce or it's something else, a lighter type and a cheaper type, because that is the most sensitive part of it. So you can glue even other materials in it to make it heavier and more steadier. But for constructions between houses, walls between houses, it makes no sense to use a very very heavy material or other material. The normal trees for making this is perfect and strong enough. But you can combine it. It's not a problem.
Thank you. And it is about questions. There are questions about the construction and some solutions. But for instance, is it possible to build in electric piping or central electric box in the ceiling?
Yes.
With CLT inside?
Yes, they make it in the wood in the factory already. Then they, what you saw, the production plant where you saw that they built the pieces together. That was wood coming from Austria. There are 6 factories in Austria and also I think 6 in Germany to make the CLT. You can speak with them to let the pipes in the wood, but you can also do it later and when you make it together. So in England, they do it in England, but you can do it in the factory already. Only that the demand of that is, of course, that you have to make a planning of every point where you want a switch in the wall or something. You must design it in advantage. You cannot do it when the building is made.
There's a question about prefabrication. So what is the generally recommended level of prefabrication? Well,
it depends a lot of what type of building you make. When you saw the hotel in Amsterdam, it is totally made from cabins, what is already completely ready with everything is inside, the lamps, the flooring, everything is in that room, and they just put the rooms together. It is very amazing to see that in the movie. There is a movie from it. And of course, that is how more you do in the factory, how better it is. But not in every situation it is the right thing to do, because you cannot split every house or every apartment in several parts, what you can make apart. It depends of the design. What you saw, the example in Eindhoven, you cannot make that in small parts and put it together. The plates are made in the right measurements and bring to the building place, and they're mounted together. So depends from what you are making, a family house or an apartment block or something like that.
There is a question about the documentation of CLT. So does the CLT certificate include the information about wood used for production or the ordered material?
I don't understand it well.
So this is about product documentation. I think that in the product documentation, it is written any information about wood used for the production.
Yes.
Yeah, so what does it contain? Product documentation about CLT.
Yeah, the documentation, which level of documentation? You have, of course, the documentation.
Product certificate.
Yeah, product certificate. Yes. That is typical something what the supplier, the factory who makes the elements will deliver. And it can be, it depends on the type of wood and so on. So it's not so easy to answer this. But of course, the factories who make this, they are certified and make it under the strict regulation what you need. But it's open to discuss with the fabrics who make the CLT products.
And but I think you don't have any Hungarian factory partner producing CLT. Am I right?
Not yet.
Not yet.
No.
And do you have any plans, or do you have any?
Yeah, we have planned ourselves. Footprint is now starting a project.
Okay.
We want to buy the ground, and we develop family houses in CLT. That is what we want to do in a zero energy level. But we let it make the elements in Austria. And they come per camion to Hungary.
Mm-hmm. Thank you. And that's why I ask it, because there is another question regarding the the ecological footprint. So the question is that what is the feasible distance from which importing wood makes CLT ecologically right and energetically also feasible, meaning LCA and LCCA aspect?
Yes, that is an interesting question, because transport is also an environmental aspect. How closer it comes, how better it is, of course. So therefore we decide to produce in Austria. That is the nearest from Budapest here. And the Germans use a lot of German wood, and the factories in Finland and in Scandinavia use the Scandinavian wood. And well, the whole chain of producing this must be as short as possible, of course.
Mm-hmm. So you mentioned some countries, and there's a question about what are your preferred CLT suppliers in Austria?
Why?
What are your preferred CLT suppliers in Austria?
Names, you mean? No,
Yeah.
I don't want to. I don't want to give names.
Anonymous would like to. Yeah, but if you don't want to answer, of course, you are the right not to answer.
Yeah, we are now speaking with 6 manufacturers in Austria, so we will see what is the best. I cannot give a name now. That's not right, I think. Then I make reclam for somebody.
Yeah, just some more questions. There is a question regarding the European building regulation system, like Hungarian, Slovakian, or any other country, that are these countries ready for CLT? We spoke about fire resistance, but regarding Eurocode and so on.
There is an, I removed it in my presentation, but I had it before. There is a website in Hungarian, and you can see that there it is written that the material is according all the European regulations. So now the certificate system is Europe-wide, and the product is good in that sense.
Mm-hmm. And, you mentioned the producers in Austria, and there's a question regarding the number of manufacturers in Holland, the Netherlands.
In Holland, 0, I think, on this moment. But there are a lot of manufacturers in Germany.
Mm-hmm.
So it is possible to use German manufacturers.
Mm-hmm. Okay, thank you. And
but I didn't do any research about this. Maybe there is already a Dutch firm. I don't know. I saw the website from a firm in Friesland and with this, and but I don't know if they make it themselves. So I don't know exactly. Maybe there is. I don't know.
Mm-hmm. There is another ecological question about forests. So the question is that, is it reasonable to fear for the reproduction rate of our forests given changing weather patterns? What area of Hungary could be considered as the steppe soon?
Well, the advantage
but is not really suitable for forests.
Yeah, if the temperature will rise in the whole world, then the growing speed will be faster. So I think there is no reason to be worried that the climate change will have influence on the speed of growing wood. I think when the climate will goes up, it will be warmer, the speed of growing is faster. I hope that is I hope that's an answer.
Yeah. And there's a question, I don't know that you know the answer for it or not. The question is, what is the proportion of imported wood used in timber construction in Hungary?
What is the
level of imported wood used in timber construction in Hungary? Do you have any data about that?
Well, I know the factory you saw of the production plant in Hungary, Grandaj, here in Hungary, and his wood, I don't know why, I never asked him, but his wood was coming from Germany. So, isn't it? Yeah. Okay. So I don't know. I think a lot of wood is imported from outside because there are no production plants in Hungary as well to make. But he is fingerprinting himself. The Grandaj also buys the wood in Germany or maybe Austria, and he has an own fingerprint machine and he produces it himself. Mm-hmm. But that's the lightweight constructions and not the CLTs. Mm-hmm. So far I know there is no production plant in Hungary.
Okay. Thank you. So we answered, or you answered more than 20 questions. And there is one more coming in. So we have 5 minutes left. So there is only one question left. And I personally have also a closing question. So the question from the attendee is, how much skilled labor is required to produce CLT? More or less than conventional construction?
Absolutely less. The advantages in the building sites when you use concrete or other materials like brick, you need much more labor to make the production. While the CLT is the fingerprints are made actually full automatic, and a few people can make a big quantity of material. And comparing that with concrete, where you have standing in the rain to bring the concrete in the mold, that is really a hard labor intensive work, and that is much less in the pre-production in factories. But the conditions are of much better for working.
Mm-hmm. Thank you. And to close the green talk, I have a question regarding your business in Hungary, because when we spoke about the footprint business, you told me that you will run a business here in Hungary around Budapest. You plan to construct family houses from the sea.
Yes.
And what about, you can tell us about your plans?
Well, I cannot show you the plans. I have made some prototypes, designs for all kinds of cases. But there is one common red line in it, that they are expandable. So you can start with a small house what has 2 sleeping rooms, a kitchen, a bathroom, and a living room, and you can expand it. So you can make an extra layer on it. That is absolutely, that must be in our opinion. And there is a big freedom of choosing all kinds of materials and colors, but that is free of the buyer, if he is known in advance, in the beginning of the project. And we only want to produce in the zero energy level. So own energy, geo-heating pump, CO2 demanded ventilation, that's heat recovery, and so on, and a high insulation level.
And do you have any?
That's my hobby.
Okay. Yes. And do you have any pilot project in the June?
No, we're just starting with that. I showed you the project I made in Holland, but that was in 2013. And I made a lot of projects in Holland, but not in this field. So I can show you very high rising concrete buildings where I was involved. But yes, we have now one in production, actually.
Okay.
And that is a private owned house.
Yeah, so thank you very much for the presentation and for the answering these questions. And in the name of Hungary Green Building Council, we wish you a good business here in Hungary. And as I told you and told the audience in my introduction, I think that, and I wish that you build net zero carbon buildings for what is good for the whole community in Hungary, for the planet as well, and for the economy. So it will be a good business for you as well.